Bolt finishes, his average velocity is 0 meters per second. Now where am I at that point? I'm here. My displacement is not 0. Therefore, my average velocity is not 0. The magnitude of my average velocity is bigger than Usain Bolt's. I'm faster than Usain Bolt. I think that's the way that works. Questions? All right. Just double checking. Yep. All right. Now the direction of velocity is the direction you're moving. So right now my velocity is positive. My velocity is negative. Because I said to the right was positive. All right. You ready? Audience participation. My position?
Positive.
There was a little bit of a stun there, but now we're back. My displacement?
Positive.
My velocity? It sounded like a 0 with a question mark. Say it with confidence.
0.
There we go. My position,
Positive.
displacement,
Negative.
velocity.
0.
All right, let's get a non-zero in there. My velocity, there we go. My velocity.
Positive.
All right, we're going to need a quicker response here because things will change if you're too slow. My velocity,
Positive.
position,
Negative.
displacement.
Negative.
My velocity,
Positive.
position,
Positive.
displacement,
Positive.
velocity,
Negative.
position.
Positive. Negative.
Yeah, that bad timing. Displacement.
Negative.
Okay. And now the tricky one. Acceleration. The scalar word is acceleration. So I am going to have to jump back. I forgot to do something here. The symbol for velocity, V with a vector symbol over it. The symbol for speed, V without a vector symbol. Speed is not S. If anything, S is used for distance or with a vector symbol displacement. All right, acceleration. If you're given a problem and you're asked what is the acceleration, which one are you being asked to find?
Both.
Usually not, but it could be. It's usually from context. And since all of you have enough experience in physics, you would read a problem and go, oh yeah, of course that's the one that the book wants or that the instructor wants. What I try to do on quizzes and tests is to actually put the symbol after it so you know which one I'm talking about. Textbooks typically, they want the vector acceleration, but not always. So it does get confusing there. If in doubt, ask. So the symbol is A with a vector symbol over it, or A without a vector symbol. There's supposed to be an A there. Acceleration deals with the rate at which velocity changes. Mathematically, acceleration is the change in velocity over the change in time. Anyone in here had some calculus? all right? For the calculus dv/dt. If you haven't had calculus, don't worry about that. As with velocity, there's instantaneous and there's average. And instantaneous is the default. And then average. All right. If, we'll do the numerically first before I do the motion. So if my initial velocity is 5 meters per second, and my final velocity is 10 meters per, let's do something, do 12 meters per second, and that I do that over the course of 4 seconds, is my acceleration positive, negative, or zero? Why?
Are you going somewhere?
There's more than that.
Because the final is greater than the initial.
There we go. Because if I plug into my formula over there, my change in velocity is 12 meters per second minus 5 meters per second divided by 4 seconds, which is 7/4 or 1.75 meters per second. So I have positive acceleration. I was speeding up. I got positive acceleration. If my initial velocity is negative 5 meters per second, and my final velocity is negative 12 meters per second, what's my acceleration now?
Negative 1.75 meters per second.
Ooh. It's not meters per second. This is 7 meters per second over 4 seconds. So that's a meter per second, or meter per second squared, yeah. Those who've had physics before, there was your opportunity to go, what were you thinking? Don't worry, there'll be other chances. So negative 1.75 meters per second squared. So right here, am I speeding up or slowing down? All right, we've narrowed it down to the 2 choices. Let's see if physics by democracy works. So 2 choices, speeding up, slowing, I guess 3 choices, speeding up, slowing down, or velocity doesn't change. That's not the answer. All right, so speed up, slow down, no change. Please have an opinion, even if it's completely unfounded and you're just doing a random guess. Who says that speeding up? Slowly getting there. 4, 5, 6, 7, 8, 9. Who says slowing down? 1, 2, 3, 4. And then I'm assuming the people who did not vote going for no change. Slowing down. What was the reasoning? Or was it just a guess?
I was looking at the negative 5 and negative 12, and like, you go from negative 5 to negative 12, that was, for me, that indicates slowing down.
Okay. What does the negative mean? If velocity is negative, what does that mean? Yes. So I'm going in the negative direction 5 meters per second, and then I'm going in the negative direction 12 meters per second. Is that speeding up or slowing down? It is indeed speeding up. Yeah, the negative sign, don't let the negative sign fool you. Negative, so we're speeding up and we got negative acceleration, we're speeding up and we had positive acceleration. So the sign of acceleration is not directly related to speeding up or slowing down. We need more information to know if someone is speeding up or slowing down. Here's another way to look at the sign of acceleration. As something that we will get into later, there's a formula we will come up with, or not, we won't come up with it, we'll just start with it. It's one of those, probably what I consider the most important formula in all of physics. F equals ma. This is that the total force acting on an object is directly proportional to the acceleration. I have only two vectors in this formula here, therefore these have to be in the same direction. So if I'm going negative 5 meters per second, so 5 meters per second in the negative direction, and yes, I know I'm not actually going 5 meters per second. I have limited room. So I'm going 5 meters per second, and someone pushes me in the direction I'm moving. Am I going to speed up or slow down?
Speed up.
So I'm moving in the negative direction, and I suddenly go faster. That means there's got to be some force in the direction I'm moving. I speed up. So if I'm forced the direction I'm moving in, I will speed up. So that would be this situation or this situation. So I can look at acceleration being positive or negative of acceleration and velocity have the same sign if speeding up. If I'm going in the negative direction and someone pushes me that way, will I speed up or slow down?
Speed up.
So if someone pushes against the way I'm going, there's hand gestures are involved. So I'm moving in the negative direction, someone pushes me that way.
Slow down.
I'll slow down initially. So the acceleration, the force, / the acceleration and the velocity are in opposite directions, I slow down. All right, here we go. My position,
Positive.
we're getting there. My displacement,
Positive.
because that's my starting point. My velocity,
Zero.
my acceleration,
0.
yeah, because my velocity is not changing. My acceleration,
Positive.
it's one of those two. You said negative?
No, it's positive.
Who said negative? Why?
It's not.
All right, so I'm moving in the negative direction, and then I get faster. If I move in the negative direction and I get faster, speeding up or slowing down?
Speeding up.
If I'm speeding up, acceleration and velocity are the same sign. Except I said positive was that way. My velocity was negative because I was going that way. Therefore, my acceleration is negative also.
I was accidentally right.
Pardon?
I was accidentally right.
Yeah,
I should have went with it.
it's that confidence. Even if you're completely wrong, just be bold about it. No, you're wrong. All of physics is wrong. I don't know who taught you or what scars you had from a childhood. It was all the hard liquor your mom fed you when you were young. Supposedly, you dip the pacifier in bourbon and it's supposed to calm the child down.
Helps with cutting in the teeth.
Mom said the bourbon just made me more hyper. Yeah, I don't want to give the impression that she was force-feeding alcohol. All right, so my velocity,
Negatives.
velocity, what direction am I going in? Positive that way. All right, so let's rewind that one. My velocity,
Positive.
all right, and I slow down, my acceleration, well, when I ask the question, It was negative, as I heard various voices say. I'm going in the negative direction. I slow down. While I was slowing down, I guess I didn't ask. Acceleration? Right. As I slowed down, my velocity was negative, so my acceleration is the opposite. Now, my velocity now. Yeah, sorry, that was not supposed to stun you. That was, I'd asked it before. All right, so my velocity is 0, and now I start moving in the negative direction. What was my acceleration as I started to move?
Negative.
I heard both answers. It wasn't 0, thank you. Which is it, positive or negative?
Negative.
Because I'm going from 0 to something negative, my change is negative. All right, so now I'm moving in the negative direction. I come to a stop. So what was my acceleration as I came to a stop?
Negative.
Right?
It would be still negative, correct, because you were wagging towards the, you would still be negative because you were going at a negative velocity, correct?
Except I was going at a negative velocity. I was doing, let's say I was going negative 5 meters per second, and then I went to 0 meters per second. Is that a positive change or a negative change?
Positive.
Change is always final minus initial. That's another one of those very few always that show up in physics. Always is final minus initial. So 0 minus negative 5 is positive 5. So moving in the negative direction, my velocity is negative. I come to a stop. My acceleration when I was coming to a stop. There we go. A couple of voices are saying it. All right, so I'm moving in the negative direction. I come to a stop. I turn around and I come back. At that moment that I'm turning around, what was my acceleration?
0.
I got a 0 and I got a negative. If someone says positive, we got all 3. It's one of those 3. And just as a hint, for the last problem on the first test, it can't be more than one of those. It's either positive, 0, or negative, despite what some students have told me in the past. Let's do it with numbers then. So my velocity, let's say negative 5 meters per second, and then 0 meters per second, and then 5 meters per second. What's my change in velocity here?
Or no, positive.
Okay, so change in velocity is positive. What about here?
Positive.
What about if I look at the whole trip?
Positive.
What do you think my acceleration is? Another way of looking at it, if I am moving in the negative direction and I turn around, the only way I can do that is there's got to be some force pushing me that way. That force first it slows me down, stops me, and then pushes me back. So the force has to be in the positive direction. Acceleration is positive. Now, I want to address the 0. If acceleration is 0, what does that tell you about the change in velocity? Sorry, let me reword that. If the acceleration is 0, what does that tell me about the velocity?
It's constant.
Yes. So if I am not moving, because if my velocity is negative and I stop and I turn around, there has to be a moment in which it's 0. I cannot go from negative to positive velocity without passing through 0, unless there's a rip in the space-time continuum. That is beyond the scope of the course. Can't go from positive to negative without going through 0. So, there's that moment when I'm turning around where I am stopped. My velocity is 0. If my acceleration is 0, what would that mean? If acceleration is 0 and velocity is 0, what's happening?
You're not moving.
So if I throw an object in the air at the peak, my velocity is 0. And some students will claim my acceleration is 0. But what would you see if I threw this in the air? If acceleration were 0 at the peak, what would happen? It would be a really cool effect. But that's just not the way that the world seems to work.
That's because there's a constant gravitational pull. so there's always only going down. In that case, you're being stopped, whereas going something, you've always got the downforce.
Yep.
So it doesn't have anywhere to stop, because it's like, oh, it's down now.
And because that net force is always down, once it leaves my hand, that net force is always down, acceleration is always down. And so when you watch the ball thrown in air, I forget what the name of the video is. There's a video where the ball problem, where I go through the plus minus zero for this. All right, I want to do at least a test level problem, or somewhat of a test level problem, and at least introduce some of this stuff to you. So when you go back to look, when you watch the videos, they'll hopefully make more sense. Questions before I erase all of this?
Yeah.
Yes.
Is there a different formula, like for velocity, you gave us the average formula. Is there a different one for finding instantaneous velocity and also like the same for acceleration?
All right, so instantaneous velocity,
It's the same.
well, you're dealing with a infinitesimally small change in time. Or from a graphing point of view, it's the slope of the line. So if I've got, well, let's look at the graphing point of it. If I have a position time graph, and it looks something like that. If I take 2 points on this, and I look at this right here, the rise, which is basically a change in position, over time, which is some change in time. My slope is delta x over delta t, which is just average velocity. So the slope of a position time graph is average velocity. If I have a curve to it, so if it's a straight line, my instantaneous and my average are the same. If it's a straight line, my velocity is constant, acceleration is 0. If I have a curve, and I want to figure out what is the instantaneous velocity at this point in position time. What's the instantaneous velocity at this point right here? Well, calculus comes in handy, but without calculus, what you would do is